Okay, good morning. Welcome to
Math for Kids number 146.
Math for Kids number 146. Let's take a little tiny step closer to me. Okay, so today we were talking about area and volume. And we learned that if we have a square, for example, whose side length is 2, what's the area?
It's 4.
4. But if we have a square whose side length is 6, in other words, 3 times as large, what's the area?
The area is 36.
Okay, and how do you find the area for a square?
It's length times width.
Right. So the side times 3 means area times 9, right?
Yep.
And if I do side times 7, what would the area increase by?
49.
49. So it goes up with the square. Sorry, I dropped the eraser over there. Can you give that to me? Thank you. And then we learned something really interesting as well, that the same kind of thing happens for cubes. Okay, I'm going to draw a bigger cube over here. Well, pretend it's bigger anyway. I don't think I drew it quite as much bigger as I was hoping for. Okay, if this cube has length 2, width 2, and height 2, what's its volume?
It's length times width times height.
Which is?
Which is 8.
8. So let's say I made this 5 times as large. So the length was 10, the width was 10, and the height was 10. What's the volume over here?
1,000.
1,000. Okay, so the length times 5 meant volume times what? It went from 8 to 1,000. So what did the volume multiply by?
The volume times...
Well, the length was times 5.
Volume times 20... No. Not 25.
Not 25.
5 cubed.
5 cubed, which
120.
is 125. Okay, and if I guess I should have started with a simpler example, but if I multiply the volume by the length by 3, the volume would go up by 27, 3 cubed. If I multiply the length by 2, the volume would go up by 2 cubed, which is 8, right? And although we haven't talked about it yet, the same thing is true for spheres. And I thought it might be fun to talk about the planets and the sun so you could see how much bigger they are. Okay? So we went online and we found for the let's see, the Earth, what did we get out? The Earth?
The Earth.
The Sun.
Jupiter.
And the Moon. The radius in kilometers. This was about 6,335 kilometers. The Sun was 695,500 kilometers. Okay. Jupiter was 71,492 kilometers. And the Moon was about 1,738 kilometers. Okay?
Yep.
So now I'm going to measure this in Earths. Okay, well, that's 1 Earth radius. Okay? The radius of the Sun is about 110 times as big as the radius of the Earth.
Yeah.
Okay? The radius of Jupiter is about 11 times bigger than the radius of the Earth. And the radius of the Moon is about 1/4 of the radius of the Earth. Okay?
It looks like 10 Jupiters is the radius of the Sun. 10.
Yeah, very close. 10 times this would be about 714,000 and 695,000. So I'm rounding a little bit here, by the way, just to make the numbers easier. These are about what the ratios are. Okay?
Yeah.
But now, let's look at the volume. Well, the volume of the Earth is just 1 Earth volume.
Yeah.
Right? But the radius of the Sun is 110 times bigger. Okay? And that means you cube that to find out the volume of the sun. So this is about 1.3 million. The sun is about 1.3 million times the volume of the Earth. That's hard to even understand what that means. But let's think about it this way. If I had a cup that was the size of the Earth, and I filled it up with water, that'd probably take a long time, right? Because I would have to turn on the sink, and it would have to fill up the whole Earth with water.
Flood the Earth.
Yeah, that'd probably take a long time. But if I had a cup that was the size of the Earth, and then I had a bucket that was the size of the sun, I could pour 1.3 million Earths into it before I filled it up.
Wow.
That's how much bigger the sun is. The radius is only 110 times as big, but the volume is 1.3 million. Now Jupiter, the same thing. The radius is 11 times bigger. The volume is, this was 1,330. So the same thing, if I had a cup the size of the Earth, and I was pouring it into Jupiter, I had a bucket the size of Jupiter, it would take 1,330 Earth pours to fill it up. Now what about the moon? The moon's radius is only 1/4 the radius of the Earth. Okay?
Yeah.
That means when I cube it, what is 1/4 cubed? Do you know how to do that?
1/4. It's 4 cubed is 64.
Okay, so what's
It's 1/64.
1/64. Okay, so if I had a cup the size of the Earth and a bucket the size of the moon, I would just have to pour just a little tiny bit in. 1/64 of the Earth. Would go
Like a thimble.
Yeah, it would be like a thimble-sized bucket. So the moon's volume is 1/64 as big as the Earth. Jupiter's is 1,330 times the volume of the Earth. The sun's volume is 1.3 million times the Earth. Okay, now for the challenge problem. If I had a cup the size of the Earth and a bucket the size of the Earth, how many times would I have to pour that in? Once. The Earth's volume is exactly the same as the Earth's volume. That's pretty interesting, isn't it? So the radius of the sun is 110 times the radius of the Earth, but the volume's 1.3 million times bigger. Whoa! Jupiter, the radius is about 11 times the radius of the Earth. So that's only 1,300 times bigger. And the poor little tiny moon. Oh, I'm just a little tiny moon. I'm 1/64 the volume of the Earth. Pretty neat, right?
Yeah.